Hello everyone, welcome back to Python Challenge for All. Okay, let's see where we were last time.
We started to move things to make animation using Pyxel. So we learned how to move, for example, move down the observatory deck, fly spaceship horizontally or diagonally, okay? So the homework, move up the observatory deck from the bottom. So let's see the code we made last time, and then maybe we can continue our trial. Okay, let's see. So open was E. Let's see, what is it? EL27, 47. Okay, it was like this. Let's run it anyway to see that it's running. Okay, so good. Every second the deck is going down and space is flying diagonally. Good. Maybe the space can be fly a little faster, right? Maybe, but that's not a big deal. Okay, so going up from the bottom, so it will be like changing this part. So the y diagonal, I mean the y coordinate becomes bigger as you go down, so it should be decreasing number. So it should start from something like, I don't know, 95. The size is 100, so it should start with something like, the size is 20, so it should start with 80 minus something, and this should be a little bigger than that, so 82 maybe minus something. Let's try this and see if this works well. A little strange. I don't like this. So maybe it's 87 instead of 80. Seems better. Okay. Ooh. Good. And stops after 10 seconds. Good. I hope you also enjoy making several variations out of these basic animation. Okay, let's move on to today's topic. Today's theme is bouncing ball. Okay, today's title is bouncing ball. What do you mean? Let's start with making a ball on a game canvas, and let's have it move around later. Okay, make a 200 by 200 canvas and place a ball at its center. I think you can do it. If you think you can do it, please do so yourself. Stop the video and try yourself. Okay, maybe we can reuse this. So save as lesson 29. Save as 29 ball. Okay, I think this will do. Okay, and let's put it here. Okay, so what's the point? It says 200 by 200. So maybe here is the title is bouncing ball. FES will start with 1. Okay. For the any initialization of class variable, these are called class variables. Just skip it this time. And just skip it and make it pass this time. Okay? So the point is, make a ball. Is there something? Yeah, here. Okay, so let's use only this and this and delete everything else and see if this is good enough. Okay, let's save and run it. It's not center. Okay, it should be center of this, so it should be 100, 100, of course. The radius of the ball, maybe 10 is good. Color is red enough. If you think red is good for you, I agree with that. Let's change a bit. For example, let's try another color. This orange, so let's use 9. And check, this is good enough. Good enough, right? Okay, let's move on. What's next? Move horizontally by 20 and vertically by 10 every second. You know how to do this. Try it yourself. Yeah, we did it last time, right? So what we learned last time was use sec variable like this, increment it every second, and add it to the x coordinate 20 times x, I mean self sec, and plus 10 times self sec. This is the one basic way to do it. As you can see, it moves fine. Okay, it goes somewhere. That's fine. Okay, we did it, but we can generalize it so that we can make it more applicable in the future. So think of position as px, by, and also let's define velocity vector vx, vy. Maybe, I hope you know that. So please learn this time if you don't understand. So to do that, maybe we can initialize the position as this. Okay, instead of using self-sec, maybe bx equals 100 self by. That's the x coordinate of ball 100 initialization. Also, we define as vertical element. No. I mean horizontal element of velocity as Vx as 20. Horizontal element, y element of velocity as 10. And what we need to calculate is that Bx is incremented by Vx every second. Vy is incremented by self Vy every second. And this part is written as, so ball is all the time at self dx, self by. And these are updated every second or every frame. Let's see how it looks like. Actually, it looks like exactly the same as before. Good. So this is a more general way to control the animation. Some object by its coordinate, usually bx, by, and position is controlled by the velocity change, by velocity every second. Okay, good. What's next? Let the ball bounce on the wall. So this is an interesting part. When you want to have the ball bounced on the wall, what we need to do when it hits the ball, multiply Vx by -1. So try programming it. Okay, stop the video and try yourself. Okay, are you by? So maybe one thing is doing it right here. In the update, if self ball x is say greater than or equal to 200. Okay, this should be something like the space size, but this time it's okay. Okay. What do you think? Maybe we can do that. Okay. So canvas X. In Python, we can do that. Canvas Y equal this time 200 by 200. And we can rewrite this as can X, can Y. Can X, can Y. So the point is, if ball X is greater than can X, then, as the slide says, multiply Vx by -1. And actually, this is all we need to do. Let's see how it looks like, the movement. Then. Oh, great. It made a seemingly good reflection, right? Of course, we need to think about the radius, but let's forget about that. Good. But anyway, this is what we wanted. Okay, next point. Multiply by by -1 when it hits the bottom wall. Okay, I'm sure you can do it. So please do it yourself. Okay, I'm sure you could do it. So the point is, maybe we can put another next one. By the way, sometimes if it's a single sentence, you can write this time. Many people don't like this, but it's a good way to save space. Okay, so if by is greater than can y, self vy is multiplied by -1. And this is all. Okay, let's run it. Boom. Good. And boom. Good. This is what we wanted. It's gone. Okay, so that's all for today. Now you learned a very interesting way to specify the position of a ball and also the velocity of a ball and how to update position using velocity vector. And you know what to do when the ball bounces when it hits the wall. So the homework, do the same for all walls. Then you can keep the ball running all the time. Okay, that's all for today. Try to solve the homework yourself and come back next time. Bye-bye.